So before we go crazy into chapter 3, we have to review what is a polynomial function. Now, if you think about it, way back in Math 10C, you learned what a polynomial is, and you dealt with a lot of polynomials. Does this look familiar? Yeah, mx plus b. You know that this actually forms a line. Oh, yippee skippy. In Math 20, you spent the majority of the course doing polynomials that look like this. X squared plus blah, 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 right? And you know that this has a degree of 2, and that gives you a nice, beautiful U-shaped parabola. But now in Math 30, what you have to realize is that we can deal with polynomials of just about any power, right? Any power. Case in point, I'm going to show you this guy. This is a polynomial function is a function in the form of, well, you can either have f of x or you can have y equals 2. It doesn't really matter. But look how complicated this looks. And it's not meant to be complicated. It's actually meant to be quite straightforward. You have some sort of a n here. You have another value here. You have another value here, which is kind of neat. But what do those a's all stand for? All those a's are real numbers. So in other words, that could be like a 2, that could be like a 7, that could be like a 5, and so on. So we actually refer to those values as coefficients. Do you remember that term? Yeah, of course you do. You remember coefficients. Coefficients are the numbers that appear in front of the x. Yippee skippy. Now, here's the interesting part. If you look at the highest power coefficient then, this guy right here. So this guy is, of course, going to be your highest power. Now, that n could be anything. It could be 3, it could be 2, it could be 1. For example, it was 1 here when we did linears in Math 10. It was 2 here when we did quadratics in Math 20. It could be 3, it could be 4, it could be 7. Yes, you're probably saying, oh my God, yeah, am I going to get a power to the 7th in Math 30-1? Yep. Sure, why not? I'm going to show you how that works. Don't worry, stick with me. I got you through this. Okay, so the coefficients of the highest power, so there's the guy of the highest power. This coefficient right here is what we call the leading coefficient. And there's going to be some important things that go along with that leading coefficient. Okay, we'll talk about that as we progress through this part of the course. Now, the next thing you have to realize is this guy out here. All the way out here, this lonely guy that has no x with them at all. This is actually called the constant. Now, you remember this from Math 20-1, case in point, or even from Math 10C. We got x squared plus, let's say, 3x minus 5. That number here referred to something very, very important. That is your constant term, but you remember that as being your y-intercept. Aha, because if you think about it, y equals mx plus b, b was your y-intercept. So that poor little old constant term out there actually has a very, very, very important role in polynomials. It gives you the y-intercept. And then lastly, this thing, the n. In other words, this front guy right here, the highest power of this entire polynomial is called the degree of the polynomial. So this is degree 1. This was degree 2. This guy here was degree 2. If I had this as x to the power of 7, then that would be the largest one. Then that would be the degree. Easy peasy. So we're going to use these ideas here when we're looking at some nice little simple examples of polynomial functions. Here's something that you would typically see in Math 10C, okay? Now, so this is f of x equals 2x minus 1. Okay, so let's start talking about this. What are the values of the coefficients? Oh, value of the coefficient, there's a 2 and there's a minus 1. There's your two coefficients. Done. Okay? Now, the highest power happens to be this front runner right here. Okay? Because that's a degree of 1. Oh, well, guess what? We just took care of that idea. But the coefficient with the highest power, so this being the highest power, this coefficient right here is called your leading coefficient. Oh my goodness, that's easy. Okay? And then last but not least, this minus 1 is your constant. Watch again. Really simple. Really a lot of fun too. Okay, first things first. Let's do this in order. Let's do the values. Well, the values here, that's got to be a 1 up front here. That's got to be a 1 up front there. And this is a -6. So your coefficients are 1, 1, and -6. Okay? Now, the coefficient with the highest power of x, okay, there's your highest power of x. That 1 is your leading coefficient. Okay? The independent term, the constant term, is this -6. It's the one without the x in front of it, and that also refers to your y-intercept. So your y-intercept on this one is -6. And then, of course, the degree in this case is going to be degree of 2. Wow, super simple. Let's do the last one then. Okay, real quick. There's your coefficients, -2, 4, -5, -7. There's your leading coefficient right there. There's your constant term right there, and 3 would be your degree. Boom, bing, bang, boom, done. Done. Okay, awesome. Let's keep on going then. Both. Okay, when we're looking at the next little thing here is we got to be able to see that polynomials also have a bunch of other things that go along with it. Okay, right? So a couple things here that you got to really, really watch out for. Polynomial functions. By definition, then, a polynomial function contains real coefficients. So in other words, they can be fractions, they could be integers, they could be whole numbers, they can even be radicals up front. As long as that radical is a real number, then you're okay with that. What do you mean, as long as the radical is a real number? I'll tell you in a second. Hold on. Hold on. Now, also, the variable here has to have really nice whole number exponents. You can't have non-negatives. You can't have, or I should say, you can have non-negatives. In other words, you can't have negatives. Oh my goodness, I'm even confusing myself. What's going on here? Real simple. Boom. That's got to be the best way to describe it. Okay? Expressions do not contain. There's no square root of a variable. There's no fractional exponent. What do I mean by that? Well, take a look here. Your typical polynomial, like x squared minus 5x plus 6. That's a polynomial. Why? Look, that's a nice whole number, right? The numbers up front are real pretty. Everything's all nice and pretty. But what if I did this? What if I put a x squared and I put cube root of x squared? No, you can't do that. The reason why is if you remember from Math 10C something called flower power, this is x to the power of 2/3. Can't have a fraction as a power. That's not going to happen. That's what this one's all about. Okay? So you can't have a fraction in your power. Okay, next one. You can't have a negative exponent either. So in other words, if I gave you something like x to the -2 plus 5x plus 6, this kind of looks like a polynomial, but the fact that you've got a negative here, no, you can't do this. Also, variables can't be in the denominator. So I can't give you something like 1 over x plus 5x plus 6. That doesn't work either. Variables have to be, they have to be pretty, like this little section in here. Okay? So, next one. Can you have a variable as an exponent? No. So in other words, you're not going to have something like 2 to the power x plus 5x plus 6. That's not allowed either. Okay? And then here's where I was saying, can you have a square root up front? Yes, you can, but they have to be real numbers. For example, the square root of 5 is a real number. Sure, it's one of those blah, blah, blah that go on and on and on forever. It'll be 2 point something. It goes on and on forever, but that's still considered to be a real number. But what do we mean by non-real numbers? You can't have the square root of -2. That's not a real number. You can't do that. It's impossible. So with that in mind, I've got a whole bunch of examples here that I want you to kind of go through with me. And I'm going to tell you right now, every one of these is not a polynomial. But you want to tell me why it's not a polynomial. Aha! So now look at this. Check this out. First things first, look at A. Do you see it? I mean, it stands out like a sore thumb. That's a fractional exponent. Can't have that. Look at this one. I got a negative exponent. Can't have that either. Check this one out. Oh, okay. Well, if you look at this, you can have a root 5, but this also means that you have the square root of x cubed. And you remember from flower power, okay, that this is x to the 3 over 2. Now, I'm referring to flower power an awful lot. If you don't remember how to do that, go back to the Math 10C podcasts and look up roots, okay? And you'll see what flower power is all about. Okay, look at the next one. Well, we got the, oh my goodness, look at this mess again. You can't have a root of an x cubed. That's not allowed either. And then finally, take a look at this. I have a square root of a negative number. That's not allowed either. So all of these are great examples of things that are not allowed to be polynomials. Okay, so whew. Now that we've got the review down, now that we know what polynomials are all about, let's start exploring them in the next couple of podcasts.